Thank you very much for this warm introduction. And this is actually my very first time I'm going to be speaking at such a large event, so please pardon me if at some point I freak out and run away from the stage. Now, it is almost 3 years since ChatGPT went public in November 22nd, and I believe none of us really imagined how it's going to change the way we work, the way we search for information, or the way we interact with technology. But also, I believe none of us really imagined how it's going to change our product roadmap. Oops, looks like it's not working. Cool. Happy Thursday, and again, my name is Ben. Professionally, I'm a UX designer with some engineering skills, which makes me more of a UX engineer. I like experimenting with tools, technology, APIs, and build real-like prototypes that I cannot really do in Figma. And actually, what's in your head you can build has been my motto ever since I joined Google Gemini Code Assist. But before that, I spent a couple of years working on products like Fitbit, Roche, Google Cloud, Empik, and so on. Now, I first experienced AI hype in my product 2 years ago. And those secret features that formerly have been just a domain of R&D teams like Google DeepMind suddenly became our top priority. And at that point, none of us, including product, business, and even engineering, had an idea how to actually jump in and leverage this technology and work together on the one vision. Today, we are all familiar with AI, but even though I still see a lot of product teams struggling with building the production-ready experience. The top 3 challenges I see is, how do I actually prompt and design LLM in a way that it always returns something viable I can use in my product? Then, how do I actually prototype the AI feature or experience, having in mind how unpredictable this can be? And lastly, how do I collaborate with product, engineering, data scientists, and research on actually moving it to the next stage and delivering production-ready quality? In short, what exactly is needed to deliver a top-notch AI feature? And I'll try to answer those questions and show you the tools that you can use to start building, but this comes at a price, though. The content I'm going to share today is going to be nerd-heavy, so please stay at your own risk. Before we begin, though, a quick disclaimer, and I'm sorry I have to do this. Whatever I share today comes from my personal experience, often trials and failures, and it doesn't represent official POV of my employer. There are going to be some mock-ups and UIs, and those are just my own explorations, not a real Google product. Now, that we made it clear, let's start with some basics. And this is going to be a slightly technical part, so please feel free to take pictures so that you can return at any time. In short, what exactly is LLM, or large language model? In general, large language models are a subset of AI or machine learning, but the easiest way to think of them is actually as of autocomplete. For example, the model starts generating one word, and then it sort of predicts probability of the next one. Each round, there is a vocabulary that it can choose from, but the word with the highest confidence actually wins. And then the model iterates and reiterates until it actually delivers the right response. I think we are facing... All right. However, but when trying to incorporate AI experience into your product, you actually need certain ways to control, extend, and then improve the experience. Let's imagine we are building a fitness app that generates a workout for a week. This means the model should be able to get users' context and preferences. Then the response has to use an exact curated workout library, not just a random information from the internet. And lastly, the workout has to fit into our user interface. There are few LLM providers on the market, including Google Gemini, that offer certain functionalities for you to manipulate and adjust model response. These functionalities in particular are prompt variables. So prompt variables are just as simple as passing variable values into specific places of your prompt template. So technically, we could design a different prompt or different set of prompts for every single use case. But instead, what we can do, we can just take user parameters and actually inject it at the right place. With that, we can sort of optimize the prompting and then allow best possible personalization. Next, we want workouts to actually be presented as a list instead of plain text. Structured output is a concept that allows you to define a desired schema of an LLM response. And when enabled, LLM will actually try to fill all of the gaps and make sure that you can actually use the response in your user interface. Oops. I'm sorry. Cool. And then the private grounding. Because we don't really want a random images or workouts from the internet, we may need to establish our own context base. Private grounding enables you to develop your sort of private search engine that you can deploy using your own data. And then whenever model generates a new response, it first looks into your own knowledge base rather than using a public one or public data that it's been trained on. With that, whatever you get as a response will be in most cases fulfilled with the data from your own knowledge base. And in some cases, we may also want model to perform some actions for us. For example, in our fitness app, we can have a functionality so that users can either rate or decide to update the workout that has been generated for them. But before regenerating the workout from scratch, we may actually want model to save this information somewhere in a database or in a spreadsheet so that later we can return, review, and improve this experience. But the cool thing is that it is not just limited to tool integration, but function calling actually is most valuable when accessing a real-time information. For instance, a weather or traffic from point A to B, or actually integrating with home appliances. So, for example, in some distant future, this app can hypothetically set up a light scene for you when you're actually doing your workout. And lastly, the most powerful one is fine-tuning. So the fine-tuning is actually about retraining model based on your own data, and this actually manipulates the default weights and parameters that are set by the model provider. A fine-tuned model actually becomes your own one, so that no one else can access it. And the most value of fine-tuning is actually, for example, in some cases, because we are a fitness app, we may want to lobotomize model to always behave in a compliant way to the users and prevent the harm. And this is just as simple as collecting input and output pairs as examples for the model. And again, in our case, whenever a user asks if they can lose more weight with Ozempic or how to actually use steroids, because we are not a medical device, we may want to do a graceful fallback and answer that we cannot help with that. The cool thing is that fine-tuning doesn't really need to be limited to the text. It also can use images. So, for example, you can provide a user's intent. You can also provide an input, another input, and output as an example for the model, how it should actually generate the response. Cool. I know this is already a lot, but please raise your hand if you're still with me. All right, awesome. Thank you, guys. Also, please write down all of the questions. There's going to be a Q&A session in the end, and I'll try to answer them if time allows. Cool. But in our theory, now that we actually know these concepts, how can we use them to prototype our desired experience? And which tools to use? There are plenty of possibilities on the market, including Lovable, OpenAI platform, Cursor, and so on and so forth, that we can use. But for some mysterious reasons, I'm most familiar with the Google tools. Again, in this demo today, we are going to use AI Studio. That is actually the easiest one to start with, simply because it has quite a decent user experience. This is also the part I'm going to be doing live on stage, so may the gods of demo be with me, and please forgive me if anything breaks in the middle. Cool. share the link, and hold a second. Boom, 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 boom. Hey guys, can we change to desktop, please? Okay. All right, cool. So again, the AI Studio, as I already mentioned, is sort of a playground that you can use to experiment with the models with the responses and some configurations. Apart from chat models, you can also experiment with the streaming data, or you can also access some latest image and video generation models in here. In our case, because we are going to be designing workout generation experience, we are going to stick actually with the chat experience. Here, in this UI, there are a couple of interesting options you can play around with. For example, you can select a model. You can provide system instructions. We're going to get back to this in a second. Then there is the temperature. So temperature is a parameter that actually defines how creative the model can be when generating our response. Then the media resolution that is more relevant for the image and other types of content generation, and the thinking mode. So thinking mode, if enabled, is actually save some budget for defining a strategy and plan before executing the task. And because this is probably going to cost you some additional tokens, you can also define a thinking budget in here. Then we do have a structured output, and this is exactly the one we'll be looking at to build our fitness generation experience. And defining structured output is as simple as providing the properties. Let's say our workout is gonna need a name, then description, and then there are gonna be a workout days, and each day is gonna contain a different set of exercises and different focus. This is why, for instance, for days, we may want to declare that it's gonna be an array or just a table, and make sure that it is an object so that we can keep adding nested properties. For the sake of this demo, I have prepared a structure that we're going to use, and I'm going to copy-paste it here. So again, this is just a JSON schema containing all of the parameters that I'm going to be using. But if you're not familiar with JSON, that's totally fine. You can just keep looking or reviewing what you did in this configurator. Next, there is a code execution and function calling. So this is exactly the place where you may want to define your own logic. But unfortunately, for some technical reasons, Google AI Studio allows us only to select either structured output or other tools, at least just yet. We are going to skip it for now. Then, a quite interesting option is grounding with Google Search. So instead of using the data that model has been trained off, it also can access the Google Search engine as a knowledge base. And in addition, you can also set a URL context, just simply passing a website data so that model has access to it in real time. Apart from that, you have safety settings. So this is especially important if you want to bulletproof your model and make sure it responds well to harassment, hate, and so on and so forth. And stop sequence, output token limit. So this is how much the model is actually going to consume when generating response, and the top P parameter. Top P parameter is also quite interesting and is similar to thinking mode, but the difference is, remember this LLM slide where I presented a GIF image. So actually, the top P can manipulate the amount of vocabulary that model actually can use when selecting the next word. Cool. Apart from that, to design our workout generation experience, we are going to need a system instruction. So this is exactly the place where you are starting drafting an outline of how the model should behave. Again, I have prepared a system instruction that I'm going to paste. All right. Awesome. And walk you through what we are doing here. Tum, tum, tum. OK. So what I'm doing here, I'm sort of asking LLM to behave as a fitness expert trainer and a workout planner, and describing what exactly is the task that I wanted to deliver. There are a couple of things that I also provide, like I describe what exactly is within the exercise database that I'm going to be using. I also provide workout schema just in case if at some point I decide to disable the structured output and play around with different tools. And then provides an information of what user is going to provide, what the model is going to receive as an input, and what are the generation rules for the workout. For example, goal alignment and difficulty matching, and equipment consideration, workout structure, and progressive overload. So for instance, the workout generated for this week should be slightly less difficult than for the next one, so that we sort of maintain this kind of progression. And lastly, in the end, I just pass my exercise database, just a JSON, and I actually took it from some free GitHub library, just for demo purposes. All right, but now that we have system instruction, what we can also want to do is to actually validate the response quality, and this is where exactly we may use a compare mode to actually figure out which kind of prompt or which kind of model actually delivers better response. In our case, the base one I selected is a Gemini 2.5 Flash, but for instance, let's see what would happen if we select, maybe Pro is an overkill in terms of generation time, but let's select Gemini Flash versus Flash Lite. Cool. So in every column, you can actually not only select the model, but you can actually adjust the parameters. You can adjust the system instruction to sort of figure out which one performs better. And let's jump to the testing and actually figure out the model response. Here in the prompt input, I'm going to pass just a simple information that my fitness goal is to tone up. The days I can spend for workout is actually Tuesday, Thursday, and Sunday, and then my difficulty level is intermediate. The time I can spend each day is 45 minutes, and as I run, we're going to see how the model generates a response. So far, what we see is that Gemini 2.5 Flash Lite actually delivered a response within around 7 seconds, while the Gemini Flash is still generating. What we also see is the Flash Lite model actually follows a nicer schema than this one on the right, so probably we are just going to skip and proceed with the Flash Lite. One additional thing worth considering is actually the tokens. So again, the token usage sort of defines how much, what is the cost of the response, and one token is around 3-4 digits. In AI Studio, whatever you do is actually for free, so you don't need to really take care about the cost. But when you move to the production stage, you may want to optimize this model, as with the scale, the cost is going to increase. Cool. We are now going to close this 2.5 Flash and proceed with a Flash Lite. Now that we validated the model's response, provided system instructions, we can actually get a code. And again, within this window, we're just going to see every single settings we defined on the UI, but don't get afraid. This is a code, but no coding skills are required at this point. We're just going to copy this code and jump back to the Build tab. Cool. Another feature in AI Studio is actually a build, which sort of allows you to ask Gemini or other model to actually code a prototype for you. And this is just as simple as providing an initial prompt and the requirements. You can attach images and so on and so forth. If you have no idea, you can start with some templates. The vibe coding actually means that you are building a real code product without actually looking into code. Cool. For the sake of the demo, I already prepared a vibe-coded prototype that I swear I haven't written a single line of code. Again, this is a fitness generation mockup that actually allows me to select a fitness goal, select fitness days, workout time, the similar information set that we tested in the prompt before, and generate the workout. Right now, it only uses a dummy data, which is not really useful for us because this is obviously not something we can test with our customers or users. As we look into workout details, we see it just uses some random images, but ultimately that's not the ways to go. What we can do now is we can actually ask AI to implement our logic for workout generation and include it into the prototype. Again, I have prepared some prompt that I'm going to be asking AI to follow. And this is just as simple as below is the code I got from AI Studio, help me implement AI service. Here are some important nodes. The logic should cover fitness generation, fitness update, log models response to the console, so that just in case I can review errors, you can access the console in here. Do not replace images with mock-up graphics. Expect model to return links to images, and so on and so forth. And actually, as I hit submit, I can already see that model starts thinking and defining the execution strategy. So this is exactly the thinking mode that we've seen in AI Studio before. Now, in general, designing this kind of prototype can take around 30 minutes to a couple of hours and multiple turns of attaching images, providing more requirements, and so on and so forth. We obviously don't have time for it, but for the sake of time, I already prepared a prototype that already has this AI options implemented. So now as I refresh it, let's test how the experience actually look like. So again, let's imagine I'm the user. My fitness goal is actually lose weight. Guess why? My workout days, I can do actual workout is Monday, Wednesday, and let's say Thursday, and remember those days. And time, let's see, 30 to 45 minutes, and my level is actually beginner. So now, as we hit generate, what happens in the background is that this prototype actually calls a real Gemini and actually generates a workout based on the preferences that we have just provided. So for instance, we see that the days that I have asked this model to fulfill are actually matching. In addition, we can see that the structure is maintained. We can see that workout details actually contain the real images from our JSON database that we provided. And we can see that there are some metadata, such as equipment, workout instruction, and difficulty level. That's all right, but that's already cool. But technically, what else we can do with this prototype? And why even use AI for this purpose? Well, with AI, what we can do is we can add even more personalization layers and test different responses and already start collecting the data. Let's see, I don't really like walking. So let's imagine, let me pass this command to the AI. And regenerate again. If we are lucky, the model will provide an updated workout, taking into account my request. Again, this should take around 7 minutes. All right, here we are. Cool. So what just happened is just I provided just a simple free text request and asked model to update the workout. And what it did is actually replace all of the exercises from all days that I don't really like and provided me with updated version. Now, technically, we could have designed this initial prompt initial prompt in here, just adding additional questions. All right, what's your equipment, or what are your preferences, or what exercise you don't like? But then this introduction form can grow quite easily up to 20 pages, and we cannot really solve all of the possible use cases. Instead, we can actually use LLM intelligence to deliver best personalization, and already share this prototype with our participants to actually start collecting the data and within this feedback loop. Now, having just a prototype is obviously not enough, and we need some certain way to share it with our customers or colleagues. And this is just as simple as deploying it as an app. What you need to do is select a cloud project. I do have couple projects created for my different prototypes, but if you don't have any, it just takes 2 minutes to create a new project and deploy it. And as you hit the deploy button, you will receive a link that you can then share later with the research participants and so on and so forth. Cool. Now let's jump back to the presentation, please. Hey guys. All right, I can see someone is running. Let's give a warm applause. Awesome. Cool. Thank you very much. Now, but enough theory. How can I actually use these concepts in my prototype and then, sorry, the wrong one. Cool. Now that we validated the prompt quality and validated our POC, how do we actually keep refining this experience and collaborate with our team? The AI Studio is cool, but unfortunately, it misses some production-ready features we may need to deliver actual production experience. Vertex AI is another powerful tool that you can collaborate with your team and keep refining your AI experience. You can actually find it in the Google Cloud, and not only it has a library of specialized model like video to text, text to image, and so on and so forth, but also it enables you to deploy a RAG engine, which is a private grounding, or tune your model quite easily using your own input and output examples. Now, for example, remember as we passed the entire exercise database to our system instructions, and this was just fine for a demo. But in production reality, we could run quite fastly out of the tokens, and this may also impact the latency. Instead, we may want to deploy our own real grounding, and this is just as simple as selecting your files, either from Drive or from your local desktop, and creating an index. As index finishes, you can actually test your grounding in a Vertex AI Studio that sort of has quite similar capabilities as the AI Studio that we've seen before. Next, as we implement the feedback loop and start collecting data, we may want to actually retrain model on our improved examples. To do that, we first need to refine collected input and output pairs and start fine-tuning job. In my experience, this is exactly where user UX and research delivers most value, brings most value to the table in selecting the high-quality examples, making sure the model responses are user-friendly, they address the user needs, and then fail gracefully. Again, this is the part where you can collaborate with a business, engineering, research on working together on the same experience. Lastly, at some point, you may want to extend your product and deliver more complex experience. Instead of one super large prompt that can easily grow to 20 pages, it's actually better to decouple your experience into smaller agents. And this is actually called a mixture of agents framework. Each agent can have own role, own tools, or input and output. But the thing is that, and also quite a cool one, is that an output for the one agent can actually be an input to another one, so that they collaborate together as a team and sharing knowledge between of them and working together on a common result. Again, as a UXer, you can help selecting the right personas for the task, defining prompts and tools together with the business analysts and researchers, and lastly, work on an output strategy. Cool. With that, I know this was a lot, but I also believe that now you probably have more understanding of what it takes to actually experiment with AI and make it more production ready together with your teams. As a last remark, I'd like to provoke you with a couple of thoughts. First of all, think beyond chat interface. There is an ocean of opportunities for different areas, for using structured output and different kinds of data. Then, assume linear logic. And this is exactly what I've seen a lot of teams failing, because as a humans or as a designers, we actually tend to design our experience as a flow and step-by-step sequence like Figma frames. And this often leads to the situation that our entire logic is if-else based. However, this is exactly where we're going to fail, because AI in general is intelligent enough to select the right strategy at the right time based on the context, and simply just if-else doesn't work here. Then, don't waste your time on designing 20 pages prompt and trying to validate all of the cases. Instead, divide and conquer those cases into the smaller chunks, into smaller agents, so that you can more easily to control them and make sure the quality is best as possible. Then, always remember to deliver a feedback loop, but not just to collect the data, but also using it to improve the experience. Now, with fine-tuning, you can actually outperform the more expensive model if you provide cheaper model with great examples. So this is an extremely important point when it comes to productionizing your AI experience. Then lastly, not really lastly, optimize your context, cost, and quality. Now that you know tools, use RAG engine or custom grounding to limit the cost spending. And lastly, use common language and tools, and meet your partners where they are. With emerging new tools to play around with AI and build something, it's quite easy to end up in the situation that everyone is using a different workspace. And it simply doesn't work. Instead, always try to select the tool that allows you to create a workspace and share this workspace with your cross-functional teams and stakeholders, so that everyone in your team can contribute either to prompting, either to model validation, even to fine-tuning, or selecting a data for the grounding. And lastly, stay curious and keep building. This is a quite interesting time to live in, and we see new breakthrough innovations coming almost every month. Yeah, with that, thank you very much.
Thank you so much, Ben. That was really full of insights. And thank you for running the demo. We are so happy that everything went smooth. We have now 10 minutes for Q&A. So are there any questions here? Yes, we have the microphone is coming.
Okay, I have a question about the prototyping itself. From your example, is it possible to export it to Figma or export it to code to GitHub, or is it vendor locked to the Google platform?
Yeah, so specifically in AI Studio, you cannot really export it to Figma because the outcome of the vibe coding is actually a real code. But what you can do is you actually can connect it to the GitHub and then access this code from there. So that whatever you vibe code in AI Studio is also going to be synced with the GitHub. And from there, if for some reasons you don't want to use Google Cloud, you are free to take the GitHub code and deploy it into Azure, AWS, or whatever you prefer.
Thank you, Ben. There was also another question there.
Hi, thanks for presentation. First of all, can you please comment some other vibe coding tools like, you know what I mean, Cursor, Cloud Code, and which are benefits of Google AI Studio to compare with them?
All right, so this is a tricky question because I myself work in a Gemini Code Assist tool, which is sort of a plugin, or is also available within AI Firebase Studio. In general, the main benefit for using AI Studio is just the user experience, and it doesn't require any technical knowledge to actually play around. And this, I mean, it has just most of the tools that you're going to need to prototype it. When it comes to other tools that you mentioned, so the Cursor, specifically Cursor, but also Firebase Studio, those are like IDEs. Those are like a notepad that engineers actually write the code. And the learning curve there is slightly higher, and it requires some understanding on how to code, how to start a project, how to create a boilerplate. So for non-coders or for people that are not yet that familiar with the frameworks, AI Studio is the easiest one so far.
Thank you. Any other questions? There is one there. Sorry, Anastasia. Thank you.
Hi. So I actually wanted to ask you regarding, either being a freelancer for various clients or working for a huge corporation. You're obviously dealing with a lot of NDA and top secret stuff. How do you? What's your take on sharing this stuff with some AI studios or AI agents, and then perhaps feeding the like the backend of the models for other people to use afterwards, and the licensing of it?
I'm not sure if I understand the question. However, I'll try to answer the other ways around. So technically, whatever you do fine-tuning, whenever you train model using your own data, this model actually becomes your proprietary data. Actually, no one has access to your fine-tuned model unless you give it to someone else. So as long as you keep your Google Cloud project private, or any other project in other platforms, and as long as you don't share this model with the public, it remains your own one, and Google doesn't really look into it at any time.
Okay, I just remembered that there was some stuff when Samsung developers were sharing the Samsung proprietary code in ChatGPT, for instance, and then other people were able to see the functions that were used in Samsung code. That's why I'm like...
Oh yeah, I mean, in my presentation, I just used the public AI Studio, so whatever you see here is just available to the public. There is no proprietary code in this prototype.
Yeah, but I mean, then later on, feeding the models, even if you have some private projects, will they be processed in the background for refining the models? That's what I basically mean.
I don't think so.
Okay.
Okay, there was another question somewhere here, right? Someone raised a hand. No? Okay, but we have a few questions here, so maybe first the front row. I'm sorry. Thank you.
Hi, Ben. Sorry, I know I promised I won't ask any questions, but I have one. I can resist myself. What are your tips on iterating on the design itself? Because you spoke a lot of the business logic, but on the design to stay consistent to the brand, to the UI.
So, in terms of consistency with the brands and the UI, technically is always well, now prompt engineering is not really a thing. Like the next stage, actually, I believe, is actually the context engineering, so that you manage the information and requirements you provide to the model, so that it delivers the best response. So one of the strategies is actually, when you want to maintain this consistency, for instance, with your design system or other or tokens or components, then you probably want to attach a design system code as a context, so that model, instead of generating something new from scratch, it looks up the context and select the right components, the right tokens, the right font sizes, and so on and so forth. So that's the one thing to iterate. Another thing, you can also, if you don't have access to, let's say, design system GitHub or whatever, you can always attach images so that the response sort of matches. It might not work like for the first time, but after a couple of rounds, 2-3 rounds, you can get quite nice result. You can also just copy-paste the token list and the values and also provide it as a context to the model. And unfortunately, not AI Studio, but there are other tools that also allow you to integrate with Figma so far, but I don't remember which one is it. But I mean, there are plenty of opportunities to play around. So
Thank you.
Thank you. And there was one more question there.
Thank you. Congratulations, Ben, on the presentation. Thanks for sharing just...
Can you see I'm shaking all the time?
Yeah, just a snippet of Google capabilities of when it comes to AI, I think. Question about prototyping. Let's say that I build something really quickly when it comes to the app, just like you shared. What about accessibility? Is it something that it's built in already in Google ecosystem of AI, or is it maybe one of the red lightsabers in the GIF that we saw? You have a special tool for that?
This is an interesting question. I don't necessarily know the answer. What I know, however, is at least in my organization, we are heavily using material design system that sort of covers this accessibility settings out of box, like all of the components that we have in Angular Material Library or any other library already have accessibility settings built in. So hypothetically, if those are built in, then even when we are web coding prototypes, we sort of take it for granted. But ultimately, again, at the prototyping stage, like the main goal is not really to test accessibility, at least in the majority of projects that I'm working on. Rather, instead, it's like validating the POC, figuring out whether there is an opportunity, how can we improve, and share it with stakeholders to get their buy-in. But ultimately, on the later stages, the accessibility becomes really important, especially when we go production.